Alright, so your quiz tomorrow is on sections 4.1 and 4.2. There's about one question from each little thing that you guys have to know how to do on your quiz, except I think that there might be a couple multiplication questions from 4.2. So you guys got to know how to do everything from the review. So let's go ahead and take a look at number 2. This one would not be a polynomial because we have that x on the bottom. So this is not a polynomial. The things that make a polynomial not a polynomial, so here's just a little side note over here. If you have an x in the denominator, if you have a negative exponent, so if it was like x to the power of -2, or if you had x under the square root, these would make things not a polynomial.
Wait, like x under the square root, could you write it?
If we, like, let's say that this one, instead of the square root being on the 3, it would be here.
Oh, okay.
So if the x was under the square root, then it would be not a polynomial. But we can have the square root, we can have the square root on the number. So like for number 3, like we have a whole x here, the x isn't under the square root, so this would be a polynomial function, and it's already in standard form because we have that x to the first power, and then no x, our constant, comes next. So what would be the degree for number 3?
What if 15x was under the...
Then it would be not a polynomial. If the x was under the square root, it would be not a polynomial. But since the square root is just on the number, then it is a polynomial. So our degree is 1. What type would that make this? Right. So we always take the highest degree, and that's our degree, and then that tells us what type. So we have that little chart that'll tell us, so this is linear. And then
what would make it constant again?
Just a number. So if it was like f of x is equal to 7, our degree would be 0.
And the type would be constant?
Yep.
Okay. Thank you.
So if we had no x's, this would be an example. All right, and then for number 3, what's our leading coefficient? Square root of 15. So it's just the number in front. So after we put it in standard form, we can ignore everything else behind it. We're just looking at our first term. All right, number 4. Is this a polynomial? Yes, and how would we put it in standard form? Perfect. So then what would be our degree here? Awesome. So once we put it in standard form, we're only looking at our first term. So our degree is 2. What is our type? Quadratic, perfect. And then what's our leading coefficient? Awesome, -2. For number 5, we just plug in the number that it gives us for x. So we have -2 cubed minus 2 times 2 squared minus 3 times 2 plus 4. So for these questions, we just have to be careful with our signs. So this negative is out front, so we're going to cube the 2 and then just tack on the negative after we cube it. So 2 cubed is 8, so this would make it a -8. Then we have 2 squared, which is 4, times -2, which would be -8. And then 2 times -3 is -6, plus 4. So then we just add or subtract here. So this is -16 minus 6 plus 4, -22 plus 4, And so our answer would be negative 18. On the quiz, I want to see this part, just you plugging it in, and then the rest you can do on a calculator. Just make sure you're careful putting in like one step at a time on the calculator. But for this one, you would just have to show your work. I want to see you plug it in. And then the rest you can just do on the calculator. Because I know like from this step, it's easy, just put it all on the calculator. Okay, I'm going to skip 6 because again, we're just plugging in. So if we have time, I'll come back to it. So let's look at 8 because we did 7 in class yesterday. So for 8, we're describing the end behavior of the graph of the function. So what are we looking at here for 8? Perfect. We're looking at our highest degree, not the negative 3. The 3x to the 5th power. Yeah, so we're looking at this one. So it's odd because our degree tells us if it's odd or even. So we're looking at the degree to determine odd or even. So that 5 tells us it's odd. And then we look at the leading coefficient to tell us if it's negative or positive. So this would be positive. So what would odd and positive tell us about our end behavior? Odd means opposite directions. Just think odd, opposite. Right, the right one goes up. So anytime it's positive, the right one goes up and the left one goes down. So down and up. So 7, we're just looking at this negative 3 x to the 6th power, so the 6 is even, negative 3, so the leading coefficient was negative. So even says that they both go in the same direction, negative means that they're both down.
Wait, negative means they're both down?
Yeah, negative and even. So even, they're either going to be up and up or down and down. So negative, even means the same. And then negative, always when it's negative, the right one is down.
Okay.
For sure. Anytime the degree is odd, they go in opposite directions. Yeah. So if you had positive 6x to the 7th power, this would be odd and positive. So it would look just like number 8. So positive means that it goes up, the right side goes up. Odd is opposite direction, so the left side is down.
Do we have to write the arrows or just like odd and positive and even and negative?
You have to describe the end behavior, so I'm looking for the arrows. So the arrows would be the answer.
Oh, okay.
Just write the arrows.
Does it matter which one's up and, I mean, like, the right or the left side?
Yes, it does. So always when it's negative, the right one is down. So it does matter which one's up and which one's down. Okay, and then 9, it gives us the end behavior, so we just have to determine what our polynomial would be. So it starts going up, ends going down. Ends going down, we said that this means that it's negative. And since they're opposite directions, that means that it's odd. So we did this one in class 2. All right, on the next page, we need to graph the polynomial function. So we said to graph, we just plug in our points, plot them on our graph, and then we need to know the end behavior. So what term here determines the end behavior of our graph? The 16 or the negative x to the fourth power? Which one tells us our end behavior? Negative x to the fourth. Remember, our highest degree tells us our end behavior. So 4 is even. So are they going to be in the same direction or opposite directions? Is our end behavior going to be in the same direction or opposite directions? Same, because it's even. So it's either going to be up and up or down and down. Which one? Down and down, because it's negative. So our end behavior here is going to be down and down. So we just have to plug in these points and then connect our dots with a smooth curve and then make sure our arrows are going down and down. So we plug in -2, -1, 0, 1, and 2. So we have 16 minus -2 to the fourth power, which would be 16 minus 16. So this is 0. So we go to the left 2, stay on 0. That's our first point. Next we plug in -1, so we have 16 minus 1, which would be 15. So we go to -1, the left one, and then go up 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So our next point would be there. Then we plug in 0. So this would be 16 minus 0 to the fourth power, which would just be 16. So our next point would be there. Then we plug in +1, so 16 minus 1, which would be 15. And then we plug in 2, so this would be 16 minus 16, which would be 0. We just have to make sure we connect our dots with a smooth curve, and our arrows are going down and down. So here, our arrows will be going down. My pencil stopped working. So we're going down, and then we just connect our dots in the middle here. So this is not a perfect graph, but for these questions we're not looking for perfection, we're just looking for our arrows. So you just have to make sure you have the arrows going in the right direction and your points plugged in. So we're looking for the points, the smooth curve, and the arrows. So these are the 3 things you need to have for your graph. By arrows, I mean end behavior. All right, let's do 11. So here we're doing the same thing. We need to plug in our points. So we're just going to plug in the same points. We have x, so -2, -1, 0, 1, and 2. So we have -2 squared plus 3 times -2 to the fifth power minus -2. -2 squared is 4. What's -2 to the fifth power?
$16, right?
That would be the fourth power.
32.
-32. And -32 times 3 would be 96. So -96 and then plus 4. So this is -88. So it's going to be off our graph for sure. But let's plug in -1. So we have -1 squared plus 3 times negative 1 to the 5th power minus 2 minus negative 1. So negative 1 squared would be positive 1. Negative 1 to the 5th power is negative 1 times 3 would be negative 3 plus 1. So this would be negative 1. So our point here is going to be to the left 1 and down 1. Next we plug in 0. So this would just be 0. Then we plug in positive 1. So we have 1 squared plus 3 times 1 to the 5th power minus 1. So 1 plus 3 minus 1, this would be 3. So we go the right 1 up 3. And then we plug in 2. 2 is going to be off the charts too, but you can go ahead and plug it in. So we have 2 squared plus 3 times 2 to the 5th power minus 2. So 4 plus 96 minus 2. So this is 98. So next thing we need to determine is our end behavior. So we're looking at this 3x to the 5th power. What does that tell us about our end behavior here? What's our degree? Is it even or odd? Odd. So are they going to go in the same direction or opposite directions? Opposite. And then, is it positive or negative? It's positive, because that's a plus 3. So what's our right arrow going to do if it's positive? The right arrow goes up, so then what about the left one? The left one goes down. So we just connect our dots with a smooth arrow. The left one goes down, the right one goes up. So our graph looks like that. So important things here that you have this end behavior, so these arrows, and then your points. So if a graphing question was multiple choice, you would just look at your highest degree, so your first term. It's not always going to be the first one, but if it was in standard form, it would be the first term. So you look at the highest degree and determine the end behavior, and just by looking at the end behavior, you can just take what was given in the multiple choice, take your options, and pick the one with the right arrows. So if this was multiple choice, all you need to do is look at the end behavior. Any questions on graphing? All right, let's do number 12. So we need to sketch the graph of the polynomial function f if f is increasing when x is less than -1 and in between 0 and 1. So let's draw our graph. Up top here, I'm going to write where we're increasing and decreasing. So everything less than -1, we are increasing. So from here until we get to -1, we're increasing. From 0 to 1, so from 0 to 1, we're also increasing. And then in between -1 and 0, we're decreasing. So here, we're decreasing. And greater than 1, we're decreasing. So everything greater than 1, we're decreasing. Was just decide where we are increasing and decreasing. So I just put my arrows up top to tell me when I'm increasing and decreasing. Now I'm going to actually draw my graph based on the next point that's given. So I just took the intervals where it told me here on the graph I'm increasing, here on the graph I'm decreasing, here on the graph I'm increasing, here I'm decreasing. So I just took the first 2 bullet points. That's not our actual graph, that's just where we are increasing and decreasing here. So I just draw the arrows above my graph just to give me a guide.
Can you do it without doing that?
Sure. If you don't want to do that, that's totally fine. I think it helps to do that just to see what you're doing. Okay, next we're going to look at this point. So it says f of x is less than 0 for all real numbers. So what does this mean? If f of x is less than 0?
That means it has to be for the left side.
Not the left. Remember, our second 2 bullet points, which this one it only has 1, either tells us that it's above the graph or below the graph. Above the x-axis or below the x-axis. So if here f of x is less than 0, is it going to be above or below? Below. So for all real numbers, that means our entire graph is below the x-axis. So our graph is going to be increasing down here until we get to -1. So there. Then we go decreasing until we get to 0. Then at 0, we go back increasing till 1. At 1, we go decreasing again. So our graph would look approximately like this. It's going to be somewhere below the x-axis. We could make it touch the x-axis here and look like that if we wanted to. It's just going to approximately look like this. So remember here, our arrows have to be going in the same direction. Not the same direction, but our arrows are what's important here. And then it has to be smooth. So for this one, it has to be a smooth, continuous graph. We will never have our polynomial function look like this. It's always going to be smooth. All of these graphs will always be some type of smooth thing here. It's just always going to be smooth. It's just the definition of a polynomial function. Just a smooth, continuous graph. All right, ready for 4.2? Olivia, yes. Yep, the 8. Oops. Okay, so for 1, 2, and 3, we combine like terms. So looking at number 1, we got to combine our x squared terms, and we just add our coefficients together. So what would we get for our first term here?
Negative 5x squared plus 16.
-5x squared. Then we combine our -6x plus 7, so this would be plus x. And then our 18 and 8, so plus 26. So we're just combining like terms. Number 2 is the same but a little bit different. Since we're subtracting, we have to distribute. So I'm going to rewrite it here. So we have x squared minus 12x plus 48. The negative gets distributed to everything after it. So this would become plus x squared minus 24x plus 63. Now we combine our like terms. So 6x squared plus x squared would be 7x squared. Yes. So then we add the negative 12x minus 24x. So what would this be? Negative 36x. And then lastly we have the 48 plus 63. So this would be 111. So our answer would be 7x squared minus 36x plus 111. So for number 3, what do we have to do first? Distribute the negative. So we're going to have negative 11x to the 4th minus x cubed minus 3x squared plus 10x minus 2. Then we change the signs for everything after the minus sign. So this becomes plus 11x to the 4th power minus 5x squared plus 7x minus 13. Now we combine our like terms. So we have x to the 4th power, x to the 4th power. What happens to negative 11x to the 4th power plus 11x to the 4th power? They cancel out. Perfect. Next, we have our x cubed. So we just have 1 x cubed here. So this would just be minus x cubed. Now our x squared. So we have negative 3 and negative 5. So what would we get for our coefficient in front of the x squared? Negative 8 x squared. Then we have 10x plus 7x. This would be plus 17x. And then lastly we have minus 2 and minus 13. So this would be negative 15. So just combining like terms. Any questions on adding and subtracting? All right. So next we're multiplying. When multiplying, we have to make sure everything in our first set gets multiplied to everything in our second set. So here we just have one thing in our first set, so we're just distributing that to all the terms in our second set. So we have 2x squared times 2x cubed. So what would we get here? 4x to the 5th power. Perfect. Next we have 2x squared times negative x squared. So what would this be? Negative 2x to the 4th power. Then 2x squared times 3x plus 6x cubed. And then 2x squared times negative 5. Awesome. Negative 10x squared. So that's our answer here. Any questions on that one? So for number 5, this is like foiling on steroids. So we just have to make sure every term in our first set gets multiplied to every term in our second set. So we start with x to the 4th power. So x to the 4th times 3x squared. What would we get there? 3x to the 6th power. Then we have x to the 4th times negative 6x. So what would that be? X to the 4th times negative 6x. Negative 6x to the 5th power. Then x to the 4th times negative 1. Negative x to the 4th power. So now we move on to our second term here. We have negative 10x squared. So negative 10x squared times 3x squared. Negative 30x to the 4th power. Negative 10x squared times negative 6x. Perfect. Positive 60x cubed. And then negative 10x squared times negative 1. 10x squared. All right. Now our third number, 25. So 25 times 3x squared. Perfect. 75x squared. 25 times negative 6x. Negative 150x. And then 25 times negative 1. Negative 25. What do we have to do next here? Combine like terms. So we start with our highest one. We only have one x to the 6th power, so we just have 3x to the 6th power. Now we go to x to the 5th. Do we have any other x to the 5th powers? Nope, so just negative 6x to the 5th. Now x to the 4th. So we have negative x to the 4th, negative 30x to the 4th, and that's it. So what would this be? Negative 31x to the 4th. Now our x cubes, just 1x cubed, so plus 60x cubed. Then our x squareds, plus 85x squared, and only one x, so minus 150x, and only one constant, so minus 25. So this is our answer here.
Miss Carter,
Yep.
do you know how many questions are good?
Okay, number 6. So for 6, when you have 3 binomials, we're just going to multiply 2 of them together and then multiply the third to our answer to that. So first thing we have to do is FOIL our first 2. So we have x squared minus 2x plus x minus 2. We combine our like terms, so x squared minus x minus 2, and then we multiply this times x plus 6. So every term in our first set has to get multiplied to every term in our second set. So x squared times x would be what? X cubed. X squared times 6 plus 6x squared. Next we move on to negative x, so negative x times x. Negative x squared, negative x times 6. Negative 6x, and then negative 2 times x. And negative 2 times 6. Negative 12. Then we just combine our like terms. We have x cubed. We need to add our x squareds together, so this would be 5x squared. Add our x's together. Negative 8x minus 12. So that's our answer. Any questions here? Number 7's just like that, but for the sake of time, I'm going to skip it. Number 8. Anybody remember the little trick we can do when we have the same number multiplied? So if we have, what do we do? So we square the first one minus the square of the second. So what's the first one squared? Then minus, and then what's the second one squared? 64. So this would be our answer. So this is just a little shortcut when you have the same thing, when you're multiplying conjugates is what it's called. But if you have the same thing multiplied by each other and the only thing that changes is the sign in the middle. So this is a shortcut.
So what if they were both the same sign?
If they were both the same sign, then you would have to FOIL, which we can FOIL here, but the O and the I in foiling, so like the outsides and the insides, would just cancel each other out. So this is just a shortcut of foiling. You could always FOIL here, but you would just get the middles to cancel out, and this would be your answer. So it just skips a step instead of foiling. If you're not confident on this shortcut, then just FOIL.
Miss Carter,
Yes.
for number 6, how come you didn't multiply negative 2x by x? Instead, you just put negative x squared.
So how come I didn't multiply negative 2? Wait, for which one?
For
Well,
number 6,
yeah.
when you did when you FOILed after you got the equation for the two like parentheses?
So here,
Yeah. Well, after that. How come you didn't multiply? Wasn't it supposed to be 2x, not just negative x?
we had to add these two together, so that's how I got the negative x.
Oh, okay.
So in this step, we just had to combine like terms, just to simplify it. All right, so let's look at number 9. In your notes for 4.2, we have a shortcut for the difference of cubes. We cube the first one, so this would be 2v cubed, then 2v squared, then 2v, and then 1 cubed, 1 squared, 1 to the first power, and then no 1. And then our coefficients are 1, 3, 3, and 1. So it's pretty much the same thing as Pascal's triangle for the shortcut for difference of cubes. And then our signs, what would our signs in between be? Since we start off with a minus, what do we put in between each term? We alternate them. So the first one always is positive, then we have minus, plus, minus. And then we just simplify. So 2 cubed is what? 8v cubed. So remember, this whole thing is cubed, so you have to cube the 2 and you have to cube the v. For this one, this whole thing is cubed, or squared, so we have to square the 2 and we have to square the v. So this would be 3 times 4 times 1, so minus 12v squared. And then this one would be 3 times 2, which would just be 6, so plus 6v, and then minus 1. So you guys can use your notes for the quiz. So you can have your little cheat sheet, I'll call it, for the shortcuts on everything. So just make sure you know how to apply them. Okay, the quiz can be kind of long, so make sure you know what you're doing. Don't just bank on having your notes in front of you and winging it tomorrow. You got to know how to do what. Don't spend too much time flipping through your notes. Okay, so we did number 10 in class on Monday, so let's take a look at 11. So we're using our Pascal's triangle. So this we said was the 4th row, so we need one more row. So we start with 1, then add the 2 above, so 5. 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then we end with 1. So these are the coefficients for our 5th degree. So then we take g, start with the 5th power. Let me change the color so we can see it. So g to the 5th power, then g to the 4th, and we go down from there. G to the 3rd, g to the 2nd, g to the 1st, and then no g. And then where we have no g, we start with 6 to the 5th power. So 6 to the 5th power, 6 to the 4th power, 6 to the 3rd power, 6 squared, 6 to the 1st power, and then no 6. So remember a little trick that we can double check to make sure we did all of this right is all of our exponents are going to add up to this 5. So 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3, 1 plus 4, and 5. So we can just double check that we had all of our exponents right that way. And then we need to throw in our coefficients in there. So we start with 1, 5, 10, 10, 5, and 1. And then since this is a plus, everything in here is just going to be plus. and then we just need to simplify. So 1 times g to the 5th power is just g to the 5th power. Here we have to multiply our numbers together, so 5 times 6 is 30, so plus 30 g to the 4th power. Then we have 6 squared, which is 36 times 10, so plus 360 g to the 3rd power. Then we have 6 cubed, so 36 times 6 is 216 times 10, so this would be plus 2,600 g squared. G to the 4th power would be 1,296, and then times 5, so this would be 6,480. G plus 6 to the 5th power, which would be 7,776. So this would be our final answer. Another helpful trick to know here, if our degree is 5, we're going to have 6 terms. So we always have one more term than what our degree is. So we have 1, 2, 3, 4, 5, 6 terms. Just like in this one, our degree was 4, so that means we're going to have 5 terms. So 1, 2, 3, 4, 5. So just another little helpful hint to know. And then when looking at your Pascal's triangle, the second number always tells you what row we're in. So this is the 2nd row, the 3rd row, the 4th row, the 5th row.